Hey there, Algebra 2. We have natural logs to wrap up the chapter. And you're thinking, oh my gosh, another thing. All right, so this has one little detail. And all it is we're going to deal with that number E that we kind of didn't really talk too much about this year. Okay, you can find it on the calculator, right? You're going to find your natural log button, which happens to be ln. Okay, and then your second function is e to the x power. So this is a constant reminder of the base, just like logs and 10 right there. And here's what it means, guys. If you had the natural log, that means the base is always e. Okay, so we just don't write it in. We just write it as a completely different logarithm, and we call it the natural log. Okay, so we're going to take all the properties, everything we've done so far in this chapter, and we're going to redo them. So this is a nice review. All right, don't think of it as something extra. So after a few problems, you're going to have this worked out. That's my hope. If not, we're going to work on it in class if I have you for class. All right. All right, so here's what it means. If you have an exponent, remember that, or a coefficient that can be an exponent. So this is natural log of 15 squared minus the natural log of 75. Now you guys know a lot of this, so it might be some review. Okay, so this is the natural log of 225 minus the natural log of 75. If I'm subtracting, what do? It's the natural log of 225 divided by 75. Okay, so that means we're talking about the natural log of 3. Right, so remember those coefficients can become exponents. This one happened to be minus, which is division. If it was plus, I'd be multiplying. So all of our properties that put those together stay the same way. All right, so the next one we're going to jump straight to, right? I'm not going to spend a lot of time on these because I don't want to take up your whole day. The next one is, remember, if there's no base, there's an e right here. It's log of x, so we're going to change it. If it's a logarithm, I have to change it to exponential. So e to the 4th power equals x minus 3 squared. All right, now if I were completely lost on this, I might start to FOIL this together, but I don't want to be lost on it. I want to take the square root right away because I don't want to get into a quadratic equation. So x minus 3 equals, if I take e to the 4th, and I also take that to the square root, which is 1/2, this is going to be e squared. Right, if you don't believe me, then go ahead and just type it in your calculator. We're going to add 3 to that to finish off the problem. So I need e squared. So e squared, I like to hit enter then, right? So I get 7 point something right there, plus 3. All right, why'd I do that? X equals 10.389. Okay, we're always fooling around with like at least 3 digits here. All right, it's a positive number going in for X, so I don't have to worry about it because we were squaring it to get started with. All right, so that is log of x. This time, if there's no base, right? Notice it looks completely different. It's a natural log now. That means we're going to use e as the base. All right, so in the next one, we're trying to get this e to the 2x power all by itself. That's goal number 1. So goodbye 2. So I'm at 14. Okay, let's get rid of the 4. By dividing. So e to the 2x turns out to be 14 over 4, which is 7 over 2. So I'm going to call it 3.5. All right, now the variable is in the exponent. So what do we have to do here? We have to introduce the log. The base is the e, so I'm going to use a natural log. Got ahead of myself there. All right, so that means I get to bring 2x down. The natural log of e, this is what makes this a little bit faster. The natural log of e turns out to be 1. So we're going to take natural log, right? So using that ln button, ln 3.5, and then divide it by 2. Okay, so we should get x equals 6.2, whoops, decimal points in front of there, 0.626, 0.626. All right, so quick review. First thing is put it together, single log. All right, so I see this has to become natural log of 25 plus natural log of 7, right? If I get 7/4, that's what natural log of 175. And the next one, right, we're going to cube this. So this is x cubed. It's over top of, I have to square all that. So 4x squared. All right, so we have some x's that can be divided here. So natural log of x over 4 is what we're after in the end. How do I get that? Coefficients become exponents. Subtraction becomes division. So I'm going to take care of each one and then hang them up. So here's what we got. We got x cubed, so natural log of x cubed times y squared times 5. I can squeeze that back in here. They were all addition, so no big deal. All right, so that's a quick review putting those together. All right, these, I don't see any bases. What's the base? Remember, you can always check, right? What's the second function of that ln? Oh, there it is. I don't know if you can read that, but it says e. Okay, so we're going to put an e down here. So x equals e squared. All right, here we go, e squared. Okay, 7.389. All right, and the next one, the natural log is all by itself, so I need 3x plus 5 squared equals e to the 4th. All right, let's get the square root. So we get 3x plus 5 equals e squared. Okay, so that means it's at 7.3. We're going to subtract 5, okay, and divide that by 3. All right, so if you did the calculator work correctly here, we got 7.796. All right, and our last one, we can also ask you to put these together. So if it's addition, we're going to multiply. So this is natural log of 6x equals 2. L-shaped box because it's a log. So 6x equals e squared. So we need that e squared again. That's 7 point something. And divided by 6. So x turns out to be 1.231 if we're following along and we're using a calculator correctly. All right, last set, we want to get this e by itself. It's already by itself. So what we're going to squeeze in the natural log to both of these. Natural log of e turns into 1. So I have x minus 2 equals the natural log of 12. So we're going to get this number on our calculator and then add 2, right? Do not use the natural log of 14. That'll throw us way off. So natural log of 12, hit enter or close parentheses, plus 2. So we got 4.485 if I round appropriately. All right, and then we have a couple little ones where it's like, all right, we have extra stuff. So divide by 2. So, e to the negative x equals 10. What are we going to do? We're going to squeeze in the natural log. So negative x equals natural log of 10. So natural log of 10 turns out to be 2.3. So divided by negative 1. So x is negative 2.303. All right, that'll work. And one more, instead of dividing the number out this time, we have to subtract it, right? So I want to make sure I'm getting this e to some power all by itself. And then we're going to introduce the log. And in this case, since the base is e, the natural log. So we kind of use those interchangeably. All right, natural log of 10 divided by 3. So natural log of 10 divided by 3, 0.768. All right, so hopefully that was a nice review of things that you already know. We're just going to apply it a little bit different. So now no base for the natural log, which we never write a base in the natural log. That's going to be e. If you have e as the base, we're going to use the natural log instead of the log. And of course, all of our properties to stick them together. They still stick. All right, keep it up.